Okay, you will understand. See, last class we have seen, we'll go quickly. Okay, so last class we have seen this parallelogram law. Parallelogram law. Okay, so what you have seen, so this two forces, okay, two forces which is acting horizontally and one force in vertically, so that is inclined. So F1 and F2, and these two forces are inclined to an angle, say theta. Okay, so what this parallelogram law says is, see, complete this parallelogram using these two forces as adjacent side of the parallelogram. The resultant force will be the diagonal of this parallelogram. So the resultant force will be the diagonal of this parallelogram. So this is my force F1 and this is my force F2. Okay, so this resultant will make an angle alpha with respect to the horizontal. Okay, to find out r vector only we wrote this formula the last video, that is on day 1. So r vector will be equal to this force square plus this force square F2 square plus 2 F1 F2 cos theta. Cos theta is angle between these two vectors, then square root of, okay, square root. So this value will give you the magnitude of the resultant. So now how to find out this alpha? See, alpha is the angle of this resultant with respect to the horizontal. Say this one is my f vector, so this is along my x. Okay, so how to find this uh, alpha? Okay, alpha, to find out, see, complete this triangle. Okay, complete this triangle, draw a vertical and horizontal and extend this line. Okay, so this line will represent your force F2. Okay, this force will represent F2 and this angle will be theta. So when this is theta, when I resolve this force into its horizontal component and vertical component, this value will be F2 sine theta. And this value, okay, this length alone will be equivalent to F2 cos theta. That means I am resolving this F2 into its constituents, okay, horizontal component and vertical component. So now you consider this big triangle. So this is the big triangle, this one is 90 degrees because I dropped a vertical with respect to this horizontal. So consider this big triangle, say ABC. So if I want to find out this alpha, this will be opposite side by adjacent side. So this big triangle's opposite side is this one and adjacent side is this one. So when I want to find out this tan alpha, okay, tan alpha will be equivalent to opposite by adjacent side. So opposite side value is F2 sin theta. Okay, by adjacent side is up to this length is F1, then this length is F2 cos theta. So F1 plus F2 cos theta. So this is the one formula we have to find out to calculate this alpha. So alpha will be equivalent to this tan inverse of this value. Okay, tan inverse of this value will give you the alpha of this resultant force, that is inclination of this resultant force with respect to the horizontal, so that you can calculate. So a lot of problems will be asked. Okay, using this formula you can directly find out the value of r and alpha. Okay, so next topic we will write this vectorial representation . Okay, vectorial representation of forces. Okay, vectorial representation, see, any force in space, okay, any force in space, say F vector. Okay, so it can be it will be having some angle, okay, with respect to the horizontal, and with respect to the vertical, say it is having another angle, this theta. So with respect to horizontal I am calling it as theta x, and with respect to y axis, so I am calling it as theta y. So this one is x axis and y axis. This force is inclined so such a way that it is making an angle theta x with respect to horizontal and theta y with respect to the vertical. So theta x plus theta y will be 90. Okay, theta x and theta y will be 90. So this horizontal component, okay, this horizontal component I can write it as Fx. Okay, this force horizontal component is Fx. So Fx I can write it as F, that is F into cos theta x. F into cos theta x. That is my horizontal component. So this vertical component I can write it as F into see, as per this how we resolve this q, okay, this f2 sin theta and f2 cos theta. In the same way, if I resolve this force into horizontal component and vertical component, it will be fx equal to f cos theta x, and this one will be fx fy, that is fy will be the vertical component, okay, of this force fy, that will be equivalent to f into sin theta x. Okay, sin theta x, that one I am writing it as in terms of this theta y. So sin theta x will be equivalent to cos theta y. Okay, so fy will be equivalent to f cos theta y. Okay, I am writing it here. So fy will be equivalent to f into cos theta y. So I am taking this angle. Okay, I am taking this angle, and this value will be equivalent to this vertical component. That vertical component will be equivalent to f into cos theta y. Cos of theta y. Actually, vertical component is f sin theta x. You know that 90 minus theta is sin 90 minus theta is cos theta. In that way, so this angle, if I take this angle, it will be again a cos. So you already know this fx equal to f into cos theta x. So along this x, so this is the magnitude, okay, this is a magnitude along x axis and the magnitude along y axis. So along this x, you know that the unit vector acting is I, and along this y unit vector is j. So if I multiply this corresponding j and I vector along this with this magnitude, it will become a vector. So fx vector and fy vector. Okay, so this f vector I can write it as f cos theta xi plus f cos theta yj. So addition of this corresponding components along x and y, if I add, I can write it as the f vector. So in this I am converting this theta x, okay, f take this f common, okay, this f and f, put it in a bracket, okay, take this f outside, and this theta x I am putting it as L, and this theta y as M. So this one will become Li plus Mj. So this L and L will be equivalent to cos theta x, and M is cos theta y, and these two are called as direction cosines of forces. Okay, direction cosines of forces. When the force is inclined in this primary axis. So this is a vectorial representation of force in terms of cos, in terms of directional cosines. Okay, so this f vector, f will be equivalent to fx square plus fy square root of f x square plus fy square root of. Okay, this is the magnitude of this f vector, magnitude of f vector. So when I know this f cos theta x and f cos theta y, so multiply, this is my fx and this is my fy. So fx square it, add it, and take the square root. That will give you the value of f vector. Okay, so in this video we will try to learn about this unit vector, position vector, and vectorial representation of moments. See, in the last class, on the last page, we have seen the vectorial representation of force. Now we will see the vectorial representation of moments. Okay, and before that, I'll try to explain this. What is a unit vector? Okay, unit vector. So unit vector for is a vector. Okay, in for example, if I am having a three coordinates, okay, x, y, and z, this vector along x, y, and z is represented by I, j, and k. You all of you know this. Okay, the unit vector of any given vector, okay, is obtained by dividing the given vector by the magnitude of the vector. For example, see, this is a unit vector along x, y, and j. You know that. For example, if I want to find out the unit vector, see, this unit vector is represented by lambda. Okay, this lambda will be equivalent to this f vector divided by f. That means the vector is divided by its magnitude. Okay, it is like 5 divided by 5. So 5 vector divided by 5. So magnitude of 5 vector divided by 5 will give you the lambda, that is a unit vector, okay, in space. So rewriting this, so I can find out this f vector. So f vector is nothing but my f lambda. Okay, f lambda unit vector. Lambda is a unit vector. F is a magnitude. As you see in the last page, that along x, that is fx cos theta x into I will give you the magnitude of the force along x. The same way for any force inclined, okay, on in space, so that force unit vector lambda, if I multiply with its magnitude, so it will give you the force vector. Okay. See, for example, if I'm having a vector, okay, f vector, okay, is represented by 5i plus 4j plus 6k. Okay, 6k vector. Okay, so if I want to find out the unit vector of this f vector along this vector, so the lambda it will be equivalent to this 5i plus 4j plus 6k divided by magnitude of this vector. Magnitude is, you know that, x square plus y square plus z square. So root of x square plus 4 square plus 6 square. Okay, so this is the unit vector of this force, of any force in space. This force is having, see, for example, this force, okay, this is f vector. So this force is having some composition along x, and the composition along is y, and along this z also. This is my z axis. So this force is like this in space. Okay, you know, I have drawn this as a coplanar and then the same plane, but the force exists in like this, okay, in space. So it will be having this I component, z component, I component, j component, and k component. So when the force is existing in space, so if I want to find out this lambda, okay, that is unit vector of this space, of this spatial force, so just to divide that vector divided by its magnitude, so I will be getting this lambda. So lambda is the unit vector of the force that you have to understand. Okay, that's lambda is drawn like this, it will be written like this. Okay, so now we will learn about position vector. What is a position vector? Okay, position vector is with respect to a point P. Okay, it is a position vector of a point P with respect to the origin. Okay, is OP vector. For example, if I'm having the write this. Okay, so this is having a force like this. Okay, a point P. So this point P is having three coordinates, that is its coordinate x, y, z. So what is the value along x and y and z? So with respect to this point, it is represented by its coordinates values x1, x, y, and z. Is some value, so 3, 4, 2 or 5, 4, 3, like that. So the position of this particular point is this much, and if I want to calculate this r, Okay, the r is the value of its from origin, so this may origin. Okay, origin 0 comma 0 comma 0. So this position vector, this distance, okay, will be given uh, relative to O with respect to, it is given by this r vector. Okay, this r vector, this length, okay, this r vector, this point up to this point's distance from the origin, this vector will be given by, okay, x minus 0, x minus 0 I plus y minus 0, y minus 0 j plus z minus 0 k. Okay, so this will be equivalent to xi plus yj plus zk. Okay, so magnitude, how you find out the magnitude of this vector r vector is x square plus y square plus z square root of. This will give you the magnitude of this position vector r, this position vector r, so that um, any point in space. Okay, this way you have to find. See, for example, position vector of any point a with the coordinates x2 y2 with respect to the point b, x1 y1 and z1. Okay, for example, if I'm having any other point, see this one, I can draw it again. Okay, so x and y and z. Okay, I am having a point a and another point b. Okay, so this point is having a coordinates values of xy, y1 and z1, and b is having x2, y2 and z2. Okay, so if I want to find out the position vector of point a with the coordinates with respect to the point b, okay, so this ba vector, so this is represented by a ba vector, so this one is op vector. Okay, and this one is op vector with respect to the origin. Now I want to find out the vector here along this line. Okay, that is my ba vector. Okay, ba vector, so that will be given by this vector, position vector from here minus this. Okay, so this vector x2 minus x1, y2 minus y1, z2 minus z1 into xy and z. So that will give you the ba vector. Okay, so ba vector here with respect to this one, okay, ba vector will be equivalent to x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. So this is the position vector of AB line. So BA vector is the position vector of A with the coordinates this one with respect to the point B coordinates this one. Okay, able to understand? Now we'll see about this moment, how this moment is. So what is a moment? Moment is the again a vector. Okay, it's a vector force which gives you some twisting effect. For example, if there is a point and having a at the distance r, one more force, yeah, force is acting. Okay, force or with the distance of r, this one. So if I want to calculate the moment, okay, m naught about this point, okay, will be given by r vector into this f vector, r into f, that is r cross f. Okay, both the vectors, so I have to take the cross product. So the definition of the moment is force into perpendicular distance about the point of interest. From the point of interest, that distance of this force from this point and the magnitude of this force into this magnitude of this force, or this cross product of this force and this position vector will give you the moment of any force about the point A, about the point O. Okay, there's R, see here R is the position vector of any point on the line of action of F. So this point R will be, can be any point on this F. Okay, this R cross F will give you the moment about this point O. Okay, so as you know very well, this R is represented by xi plus yj plus zk, and this f vector I can represent by fxi, that is fx is this any force. Okay, I'm having a force here, say F vector, so this position, okay, this value along this x-axis will give me my fx, okay, fx plus fyj plus fzk. So here if I represent, this one is my fy and this is my fz for any vector f. So corresponding x, j and k into this fx, fy and fz will give you the f vector. In the same way the position vector of this one, this is r, okay. So this is so r cross f. So this position, this r, this is my force f, okay, this is my force f and this is my r. So this moment will give you the moment is calculated by r cross f, okay. So r cross f, okay, so this will be written as that is my moment, okay, m vector, okay, m vector about the point O. So this will be the determinant of this matrix, okay, ijk. So the unit vector along x, y and z, then this corresponding coefficients, okay, x, y and z, and this one fx, fy and fz. So this m vector, that is a moment, can be calculated by the determinant, solving this determinant, finding also this moment. Again it is a vector quantity, okay, in terms of xz, I, j and k, okay. Its unit is that this force is in Newton and distance in meter, so this unit of this moment will be Newton meter, okay. So how you calculate this moment along this, if I find out this determinant, okay, for I, so it will be f z y minus f y z into I, then x f z minus f x z into j, okay, plus k into x f y minus f x y. So that is the determinant value in terms of I, j, k. You know that how to find out the determinant of this particular matrix. So that will give you the moment of any vector in space with the perpendicular distance r. Able to follow this? You have just understand that this r cross f is not equal to f cross r. Okay, it will give you the you know that in matrix, okay, this r cross f is not equal to f cross r in a cross product, okay. It will be entirely different if you take this moments, okay.